In this video, we're going to rederive the law of cosines from the properties of the dot product. So we're starting with some useful facts about the dot product. A, it's distributive and commutative. So commutative means you can reverse the order. Distributive means it has a property like this, where if I dot a vector into a vector sum, it splits up into the dot product of that original vector with each piece of that sum. And this also implies that something like FOIL will happen if I dot two vector sums into each other. You just apply the distributive law twice and it all splits up. In B, we're reminded that a vector difference v minus w is a vector that points from the head of w to the head of v, provided their tails are in the same place. And that's exactly what we see in the picture. So I have v and w with their tails in the same place, and v minus w pointing from the head of w to the head of v. This forms a non-right triangle, which is the whole context for the law of cosines. In C, we're reminded that the dot product of a vector with itself gives you the square of its magnitude. And we're asked to use these facts to derive the law of cosines. So the way the law of cosines is normally phrased, we would call one of these side lengths that's adjacent to the angle, we would call that A, the other one we'll call B, and then the one opposite to that angle, we'll call that magnitude C. And the law of cosines relates all those magnitudes, A, B, and C, and the angle theta. So the way I want to start is by looking at that magnitude of the vector difference, the thing we called C, and we get that by dotting that side into itself. That would give us the squared magnitude. All right, that's going to be C squared. But on the other side here, I'm going to expand that by using the distributivity of the dot product. So it breaks into four terms. I get a v dot v minus a v dot w. So I'm just using FOIL here, minus a w dot v, and plus a w dot w. Then I can relate all these quantities to a, b, and c. So v minus w dotted into itself is the square of the magnitude of that vector. That's just c squared. V dotted into v, that's the magnitude of the vector v. That's a b squared. W dotted into itself, that's a squared. And then I have these two terms in the middle. I have this negative v dot w and then minus w dot v. And this is where I have to use the commutativity of the dot product and say that the dot product works in either order. So I can express both of those as a v dot w, and I end up with a minus 2 v dot w. And then I have to use the geometric definition of the dot product. And while I'm at it, I'm going to put that a term first. So a squared plus b squared minus 2. And then v dot w is going to be the magnitude of v times the magnitude of w. So 2ab times the cosine of the angle between them. And we just retrieved the law of cosines from the properties of the dot product. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.